finish spirals, let's finish polar, then we're on to vectors. I have one page on vectors. What? Well then. All right. Nobody, how many sets do you need? Three? All right. Here we go. Is this thing recording? Oh, well. Okay. Did we do two spirals or one? Talk to me, people. One. What do we do first? R equals theta. Cool. R equals a theta is generally speaking a spiral. Okay? Let's say we went backwards. If I gave you, given the spiral with points, let's go with 0, 0, obviously, 2 pi over 2, 4 pi, find the equation. So it's going from 0, 0 to pi over 2, 2, pi over pi 4. It's spiraling out pretty hard. Now basically, you can tighten or loosen the spiral based on that A coefficient. And so that A, magically chosen, is making it pass through these points. Fine. Go. There's really only one thing you can do that fails, which is, of course, what 6th grade, 5th grade chose to do. There's only one epic failure. Got it? Okay. Oh, yeah. It really only takes 1 point to find it and 1 point you could use for a checkpoint. 12. Boom. I hope these classes are better balanced next time. Sheesh. I don't know. All right. Have a look. I don't know what I'm doing right now. Okay. So what did you say? R equals a theta. What can you do to find A? Plug in a point. 2 A of pi over 2. A is 4 over pi. R equals 4 over pi theta. Check. Okay, what's the only point you really couldn't use to get you anywhere? Yeah, 0, 0, which, like I said, is, of course, the point they chose in the last class. Okay, yeah. Graphing lines. Now, these are lines through the origin. With y-intercepts, other than the origin, are a little bit of a different ball game. We're going to just focus on the ones through the origin. Say I asked you for the equation of this in polar. What is it? What do you know versus what do you not? Yes, go ahead. Sure, go for it. Okay, give me not, is it minus though? Wouldn't minus be this way? So I like theta equal pi over 6. Give me another possible for that, in case that wasn't there, multiple choice was. Give me another one. 7 pi over 6, yeah. Now wait a second, wouldn't that be pointing me this way? Is that okay? How would I get points this way? If R was, can R be negative? Sure, why not? It doesn't say, so you might as well. Okay, so theta equals 7 pi over 6 would work. theta equal 11 pi over 6 would work. Theta equal negative 5 pi over 6 would work. All those would work. I think it would be 8 because r can be positive, negative, frontwards, backwards. It's all good. All right? So theta equals some angle is a line through the origin. That same problem, would you give me the rectangular form or the yx form? That goes to maybe reference triangle. What are the sides of a reference triangle for 30, 60, 90? Remember back to algebra 2? If it's the unit circle, this is 1, this is... Ay, freaking yay, are you kidding me? Root 3 over 2 and 1/2. Give me the equation of the line now. What's the slope of the line? The rise over the run. It's rising 1/2 and running root 3 over 2, and I'm crying because you swung and missed it that one. 1 over root 3x, yeah? Okay. Would you graph for me theta equals pi over 7? Or sketch. What do you say, youngsters? It's a line. Yes, it is a line. In what direction? Where is it in reference to another reference angle? A little below pi over 6. Is it a ray or a line? It's a line. Okay, so somewhere in there, right? Okay, that is that. Let's go on to vectors, set 108. All right. Okay, we'll watch a clip of Despicable Me. FERPA.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah! Check out my new weapon. Piranha gun! Oh yes! Fires live piranhas. Never seen one before? No, you haven't. I invented it. Doing a demonstration. Oh, ah! It's so difficult sometimes to get blind thoughts.
That's a good one. All right. Oh.
Hey.
Oh, goodness. All right. Oh. All right. So I will offer you the same extra credit every class ever gets, and that is if on the test you come to the vector problem, if you are willing to get up and go, oh yeah, I will give you extra credit. I'm serious. Okay?
You got it.
So,
I have no dignity.
exactly. If you're willing to trade your dignity for a few points, go for it. I know I would. I would trade it for no points. So, whatever.
Can I do it on every test?
On every test you get
Any time there's a vector problem? Sure.
Oh, that's
Okay? Every test extra credit points. And usually it's either a sign of desperation or there's sometimes where the whole class, you know, if they all get to that question and they all look at each other like, are you going to do it? I don't know if I'm going to do it. So they either all do it or don't do it, but whatever. Okay. Here we go. I will try and touch on 3 dimensions to some extent, but I'm going to focus on 2 dimensions because that's Calc 2. Calc 3 is 3 dimensions, but if I can get you a little bit here and there. All right. So vector is a quantity with both direction and magnitude. Give me a real-life phenomenon that we use a vector to model. Okay, how about, I guess that was too broad. Velocity, for example. Does it have direction and magnitude?
Yes.
Does speed have direction and magnitude?
No.
Okay, so speed is a scalar, velocity is a vector, right? You could also use force and a lot of different things here. Now, this is all going to be math world, not necessarily physics world, all right? Although I'm sure there's a ton of overlap. I don't know if it's all perfect agreement. This is math time. Now, there are two typical component forms you'll see written. They both involve horizontal first and vertical components second. You sometimes see bold. It's used in books to denote a vector. However, when you're actually writing calculus, it's really hard to write a bold letter without just really. So you don't typically use bold in your own work. This is used for our work. We use this. The little vector over it to show vector u. Okay? The horizontal and vertical components can be broken into I hat and j hat, or vector I and vector j, where I is 1 unit horizontally and j is 1 unit vertically. I personally prefer this form, this pointy form. That shows horizontally A and vertically B, but it's less writing than I hat and j hat. So you will, when I do component form, I typically use the right notation. It's up to you though. If you go in 3 dimensions, then instead of u being just I hat and j hat, it's also k hat, all right? Which is the z direction. Or if you like, A, B, Z, in order triple, not in order pair, all right? Polar form is typically done in this little angly kind of form. R is the magnitude. Think of it as the length of the vector. I'll call it maybe vector u. The notation for magnitude. How do you show, hey, find me the magnitude? You guys, what notation would you use for magnitude of a vector in physics? No? Okay. All right. In math, if you give double bars around a vector, that is the magnitude of the vector. It's not absolute value or super absolute value. It's magnitude of the vector. So for example, if I say, given u is this, and ask this, then I'm saying, how long is that vector? And how long is that? It might help to draw a picture. This is right 2, up 5. It is a magnitude of root 29. Okay, the vector magnitude is the Pythagorean theorem, right? You with me? Are you with me? Okay, if you take a multiple of a vector, then you just multiply each component. Say, for example, you're given vector u is negative 4, 5, then 3u is triple both components. So, negative 12 and 15. That's a scalar multiple of the vector or scale factor. Okay, you follow? So far, so good? Okay, great. Thank you for that feedback. Here we go. Moving on. All right, graphing vectors in 2 space and 3 space. A vector can be drawn anywhere. So if I ask you to draw vector u, negative 4, 5, 1, 2, 3, 4, 1, 2, 3, 4, 5, left 4, right 5, I could do that. Now that's the one that students are drawn to because it's in our habit to start at the origin. But for vectors, there is no requirement that you start at the origin. All you ask is that from some point in space, you go left 4 and up 5. So I could just as well draw vector u starting here and going there. That's vector u. Or I could start it here. Now, surely they'd all be the same length in the same direction, and they're all vector u. The initial point, unless given, can be anything you want. Now, those are all the same direction, but they have different initial and terminal points. Sometimes they will give you the points and ask for the vector between them. So if, for example, I said start at the point 2, 4, which is point P, and then draw the point Q, which is 4, 1. Vector PQ, that's P in the direction of Q, and so PQ is that vector. Now, vector PQ then would be how far did you go horizontally and how far did you go vertically. Now, just visually, how far did you go horizontally? 2. And how far did you go vertically? -3. Say we didn't graph it. Where did this 2 come from? In terms of the original points. x2 plus x1, x2 minus x1, x2 minus x1. The difference between the two x's. And that is obviously then y2 minus 1. Cool? All right. Say then we did this in 3 space. If I asked you to sketch the vector 1, 2, 3, we'll use the right-hand coordinate system, which is to say x, y, z. Most students prefer the left hand, which is x and y in their normal places, and z is coming out. That's the left-hand system. We're going to use right hand because if for no other reason that students don't like it, that's good enough for me. 1, 2, 3 is 1 in the x, 2 in the y, 3 in the z. Now, the problem then, if you were to draw that in 3 space, it's not really clear where the heck it is. So it's very common that when you do points and vectors, you draw a box around it. So let me go back and show you how this would typically be shown. You would go 1 and then 2. You could say then that that really kind of makes finds a point in the xy plane. You with me? That parallelogram that's made then, if you take each of those 4 points and go up 1, 2, 3, then you start to get more of a box. Now that box then makes it clear how things are rolling. Now you can draw the vector from the initial to that point. And the reader kind of has a feel for, oh yeah, I feel like that's 1 in x, 2 in y, and 3 in z. Okay? So you draw this box around to help with perspective. You follow? Okay? Let's go to polar. You need to be able to convert, just like in polar coordinates. Vectors, you need to make jumps from rectangular to polar back, and it's a lot of the same kind of thought process. If you have any vector with an r and a theta, then the I hat component is r cosine theta. And the j hat component is r sine theta. The horizontal and vertical parts to that vector are fractional parts of the overall magnitude. Cool? So if I had 4 at an angle of 2 radians, what quadrant is that? You don't need to draw it, but what quadrant is that in? many radians is this about? About 1.57 radians, and this is about 3.14 radians, so 2 would be in here somewhere. Okay? At any rate, you don't need to draw it just for fun, just to get you thinking here. How do you put this into component form? What's the horizontal component? For cosine of 2 radians and the vertical for sine of 2 radians, whatever those are. You with me? Questions? Okay, so far so good. Let's go the other way. Converting to polar. This one I like to have a picture on. Now the reason a picture is good is a picture tells you how to relate alpha for lack of that. It's not said very well, but you'll understand in a second. Okay, it helps you find the theta. We need r and theta. Let's start by finding r. How do you find r? Pythagorean theorem. Okay, you can also say that's the magnitude of u, just getting some practice. R is the same as the magnitude of the vector, how long the vector is. So what is the magnitude of the vector? Square root of 41. Yeah? All right, the angle, you're going to find the related angle and then adjust it based on where it is on the coordinate plane. So what's theta, what's alpha? That's here, sorry, I'm referring to this. Strip the sides off, don't worry about the sides of the length. Inverse tangent of 5/4 or 4/5? 5/4, okay? Now you don't want to use the signs because that puts it in the first and second quadrant, and it's just take the angle itself, all right? Now, what about theta then? Is theta, that alpha, more than pi over? Do I ever use the pi over 2 and the 3 pi over 2 as a starting point? Never. Okay, you always use 0, pi, or 2 pi. So, in relation to that alpha, what's theta? Pi minus alpha. Okay, so theta is pi minus alpha. So in polar form, then we could say this is root 41 pi minus the inverse tangent of 5/4, whatever that is. If this is no calculator, you just look it up. Cool? Questions so far? All right, you're a quiet bunch. It's been a long week, apparently. All right, adding vectors. There are two accepted ways to draw vector sums. The parallelogram method and the triangular method. I don't care what you use. You're going to make the same picture either way. It's just a different thought process. So, say you added these two vectors. When you add two vectors in component form, it is permissible to say horizontal of 2 plus horizontal of 4 equals a horizontal of 6. And 3j hat minus 5 is -2. Okay. So the sum of those two vectors would take us right 6 and down 2 overall. Okay? Drawing this, you could draw the parallelogram method. Think both from the origin. That'll make sense in a second. If you start at the origin and do vector u, 1, 2, 1, 2, 3, there's vector u. If you start at the origin and then do vector v, it's right 4, down 5, there's vector v. Now, the sum of those two vectors, I like to think of two strings pulling on that. Wouldn't those two together share an effect of somewhere in the middle? Yeah? If I were to look at the result of those two forces working together, you could picture it by a parallelogram. If I copied this guy here, it would be right 2, up, So a copy of that guy would be something like that. And a copy of that red would be something like that. The net result then overall, or the sum of the two, is actually that guy. That diagonal is u plus v, and you can see it looks like right 6 down 2. At least if I get it well to scale. You tracking? All right. That's the parallelogram method, where you do both from the origin and you draw the diagonal. Most students prefer the triangle method, which is the head-to-toe method kind of thing. If you start with u, 1, 2, 1, 2, 3, and then rather than going back from the origin, go from there in B, then from this point, I'm going to go the V directions of right 4 down 5. The overall sum of those two vectors then is the result of starting at that point and doing both. That's u plus v. And you can see it's also right 6 down 2 and exactly the same as the u plus v over there. You see? Okay. How about in polar? If you add in polar, this is adding in component form, and we can just add the components. What about in polar? Can you add 3 and 4 and add the angles? Is that a yes or no? That is a big no. Okay. That would be like if I said, hey, pull on this string at 90 degrees with 2 newtons, and then add to that a force of pulling 90 degrees at 4 newtons. Together they would be a 66 force and 180. That doesn't make sense that those two would send something in the 180 degree direction. You cannot add the two in polar form. You must go to components. Okay? Now, if you were to add this in components, what's the horizontal component? How would you find the horizontal component to that first vector? Okay, let's go back here. There is a, nope, it's down here at the bottom. When I had the vector 4 at an angle of 2 radians, what was the horizontal component? 4 cosine 2, right? So if I have a vector here of 3 at an angle of 2 radians, then the horizontal part of that vector is 3 cosine of 2. And I would add to that the horizontal component to the other vector, which is 4 cosine of 5. That sum would be the total horizontal of the two. What's the total vertical of the two? 3 sine 2 plus 4 sine 5. Okay? Now that would be rectangular. If they wanted it in polar, then you would have to take that and convert it into polar by finding the Pythagorean theorem magnitude and the angle inverse tangent kind of stuff. Okay? And back to polar if necessary. Okay. Subtracting vectors slash drawing a subtraction of two vectors. Again, there are a couple ways to think about this, but I'll go the most common. What is u minus v? If here's u and that's v, then what's the components u minus v? 2i hat and negative or positive 3 minus negative 5. So plus 8 j hat. Wait, you following? Are you with me? That's what I said. Sorry, negative 2i hat plus 8j hat. Is that better? Yeah. Okay, sorry. If we were to sketch the three vectors at play here and how they relate to each other or where they are in relation to each other, u is right 2 up 3. And we'll draw that in standard position, which is to say for the orange. 4, negative 5 is right 4 down here. Okay? Now if I were to picture u minus v in relation to those two, would I go here from the end of E towards U, or is it the other way from the end of U towards V? Well, look at what we have here. The sum is supposed to be negative 2, 8. So is that red good, or is it the green? Which of those depicts negative 2, 8? The red. Yeah, the red is the way to go. So it's from A towards U. Okay. Here's U. Okay. In the last class, they said, couldn't I go U plus negative V? So they went from U in a triangle way, and they said negative V would be left 4, up 8, and that's actually exactly, this vector then would be exactly like that vector. So it's the same equal. All right, but it's this triangle is more common. Okay, unit vectors. What does unit mean to you in math? Unit means 1. Okay? Units are a type of measure, but unit is 1. Unit circle is a circle with radius of 1. Unit vector is a vector with a magnitude of 1. Vector with magnitude equal to 1. Okay, cool. In the same direction. So they're giving me some vector u that goes left 4, up 5. There's the original u. How long is it right now? Right now, it's too long. I think you'll agree the magnitude of that is not 1. It is root 41, yeah? In other words, it's about 6.5 units long. We want it to be 1 unit. So how do I still go in the same direction, but only make it 1 unit? What? Okay, you want it to go in the same direction, so I'm going to keep the components, but I'm going to shorten it by dividing it by a factor. What factor should I divide it by? Yeah, same components. Components, but divide by the magnitude. Shorten it up. So, negative 4 divided by root 41 and 5 divided by root 41. What if I ran the Pythagorean theorem on my new vector to find the length? How long is it? How long is it? Better be 1 or it's not a unit vector. What is, if I squared that at 16 41st and squared that at 25 41st, the sum is 44 44 is perfect. In business, right? Okay. Find the vector tangent to the curve, starting with a little bit of calculus. Find the vector tangent to the curve. Y equals x squared minus 2x plus 1, or if you like, x minus 1 squared, at x equal 1 in sketch. That is a parabola shifted right 1. At 2 is this point right here, and here is the vector. I guess I'll call it V. Doesn't say how long it has to be, so I guess I'm not going to sweat that. I will let it be however long it wants. Focus on the direction. How do I get to direction? Tangent implies? Derivative, yes. Okay, dy dx at 2 is 2x minus 2 at 2, or 2. Please, it's helpful to make it a ratio. So call it 2 over 1. What is the vector then? Vector v is what? Component. To go in that same direction, I would want it to slope the same, which would mean I want it to rise and run the same. So 2, 1, right? 1, 2. What comes first, horizontal or vertical? Horizontal, okay, so it's 1, 2. You go right 1, up 2 for vector v. B, find a unit vector tangent to the curve at x equals 0. That should be pretty easy. Shouldn't require a lot of thought if you think visually. I can think of 2 different answers. Give me one. You're killing me today. You are really making me work, huh? Do you agree there's a horizontal tangent at O? I see. Right now you're thinking. Sorry, I'm tired. I was thinking that this was at the origin. Never mind. At x equals 0, we're at here, right? Is that why you're looking at me like I'm, because this isn't 0, that's 1. I see. I'm with you. Sorry. Take it back. Go. Sorry, I was thinking at x equals 1. Yes, I am doing this problem. Okay? Did you get the, yes, sorry. So, good question. These are the same, and so good. We'll come more to this later, but yeah, you actually have 2 possible answers. One is -1, +2 for left 1 up 2, or you could also say right 1 down 2. They're both acceptable. Good point. So either way, it's not a unit vector yet. It's too long. So what do? Divide by the magnitude. So either 1 over root 5, -2 over root 5, or -1 over root 5, +2. Check. Okay. In Calc 3, I'm not going to go into this, but you'll have sheets and stuff like this, and you'll have both vectors and planes tangent to the curve, all in good time, but that's in Calc 3. All right, unit vector normal. There is a little bit of vocabulary. Math people, they can't make it easy. They got to throw extra vocabulary to make sure you're really part of the club. So, perpendicular, normal, and orthogonal all pretty much mean the same thing, but based on an educated person, you would use them in different times. If you say line, you typically say lines are perpendicular. If you say vectors, you don't say perpendicular. You say vectors are orthogonal, which is one of my favorite words to say. Orthogonal is the word for perpendicular when you're talking vectors. Okay, so when you hear orthogonal, think perpendicular. Right? Okay, Mr. Ricklin, you got it. Sketch and find the 2 vectors orthogonal to 5, 2. If I gave you vector u, which is right 5 up 2. There are 2 vectors orthogonal to vector u. How could you stay perpendicular to u or go perpendicular to u? How do you, when I say the slope is 2/5, what's the perpendicular? -5/2. So wouldn't you agree we switch the components and put 2 negatives on or 1? 1. So one possibility of orthogonal is instead of right 5 up 2, we go left 5, left 2, up 5. So one possibility is -2, +5. What's another possibility? Two negative. You can see that to make a perpendicular, you switch and negate one. Okay, now, actually I lied a little to you. I said there are 2 vectors orthogonal. That's not true. How many really are there? If you don't limit yourself so much. Yeah, there's 1, 2, 3, 4, 5, infinitely. So truly a disk is made by all the orthogonal vectors. All right? A unit vector normal to y = sine of x. Let's draw a picture just to aid our understanding. Here's y = sine of x. Here's pi/6 about here. A vector tangent would be this way. A vector normal would be this way. It needs to be 1 unit long. So I'm looking for a perpendicular vector to the curve of pi/6. Are you with me? Okay. Your normal 2 vectors are orthogonal to each other, but this isn't 2 vectors. This is a vector or perpendicular or normal to the curve. All right, so that's why I'm not using the word orthogonal, because it's not 2 vectors. Let's go with finding the tangent first of all. What's the tangent? Y dx is cosine at pi/6 is √3/2. As a vector then, what are the horizontal and vertical components of the tangent vector? √3/2 or 2√3? 2√3, okay. Now let's go normal. What's a normal vector to the curve? One of 2 possibilities. -√3, 2. That would be the one I have shown rather than the one going down right. Okay? Now, to make it a unit normal, we need to shorten the length. How do we shorten the length? Divide by the magnitude. So we divide by the magnitude, -√3 divided by the length of the curve makes it 1 unit long. How long is the vector right now? 7. So we'll have, or square root of 7. So we'll divide by the square root of 7, or divide by 2 or 3-ish to make it shorter of 1 unit. You with me? All right, almost done. Last but not least, it's often the question that you don't want it 1 unit long. You want it 3 units long, or 10 units long, or 20 units long. So finally, find a vector of length 3 in the same direction as vector u. I'm going to draw a picture just to close. All right now, that vector u is probably about √29 or 5.5-ish long. I want it to be 3 units long. What is that vector in the same direction? But only 3 units long. What do you reckon we should do? Yeah, find a unit vector, take it down to 1 unit long, then stretch it out to 3. So a unit vector would be 5/3 root 29 and 2 over root 29. And then to stretch it, you multiply by a scalar. So 15 over root 29 and 6 over. Okay. Try the last one on your own. That's about as rough as you're going to see for today's problem set. And if you can do that, you'll be in good shape. That combines a lot of the little skills we've done today. Okay. See if we agree. That's one of two possibilities. Do you agree with negative 21 over root 53 over root 50? No? Yes? Okay, cool. That is that. Oh, yeah. Do we have time for 3 minutes? Shut it down, baby. Shut it down. Close those books. So we're not turning anything in? Seems kind of wrong. Doesn't right, am I right? Doesn't feel right. That folder's getting a little thick. Look at how thick that folder. Is this all problem sets we have backed up?
We don't have that.
How many do we have?
Like
2? 2?
well, okay.
Now 3. So now you have 106, 7, and 8?
Yeah.
105? You have 105?
106 fun sheet. Yeah, we have 105.
And 106 fun sheet? You still have 105?
We have 105. We don't have the 104 fun sheet.
Oh, yeah, we do.
There's a 106 fun. Wow.
We unpacked it.
105,
Realize there's a fun packet.
105, 106, 106 fun packet, 107, and 108?
Yes.
Oh. Wow.
Yeah, you never put the key on like 105. And we never went over questions. That's why we still have to.
Alright, I'll put all keys on mine. We gotta get caught up. I gotta get through 112 this semester. I got a pace to keep. So let's see, that's pretty much. I'm gonna give you the review, the final review next Friday. Test next Friday.
We have a test as well.
Harder test.
We
Oh, not you.
The interruption, maybe AP physics students to report to the classroom right before 7 hours, so in the 10-minute passing period. AP physics students, please swing by the classroom. Thank you.
Oh shoot, I forgot to give you your 5 labs.
All right.